Hello friends, this is Durga again from IT Varsity, a one-stop shop to learn all the technologies. At this time we are talking about big data workshop, and we are in the middle of Hive. So as you guys know, this is the backup for the live audience. And if you are interested in learning by watching these videos, and if you need environment to practice, please go to labs.itvarsity.com and sign up for one of these plans. And if you have any questions, I might not be able to answer your questions on live chat, YouTube's live chat. Rather, you have to use discuss.itvarsity.com after the class, and you can ask any questions. That being said, now let me set up the WebEx session, and then we'll get started. Hello, friends. So let me share my screen. So far we started with Scala and Spark workshop, and then we have seen HDFS a little bit, and then we have also seen Flume, Kafka, and Spark streaming. After which we are actually talking about Hive. So far we started with the Hive DDL, and we also covered Hive DML. As part of that process, you should understand the difference between managed table and external table, partitioning in Hive, bucketing, and then loading data in Hive tables, either by using load command or insert command. And also Hive transactions are just started recently, but they are not extensively used, so you can actually give low priority to Hive transactions. And coming back to the certification syllabus, Hive DDL is not within the scope of CCS, Spark, and Hadoop developer. If you are planning to give CCA data analyst, you should focus on Hive DDL. For CCA, Spark and Hadoop developer, as well as CCA data analyst, and also for HDP-CD Spark, we have a component called Spark SQL. And there is a significant overlap between Spark SQL and Hive. If you know Hive, most likely we'll be able to use Spark SQL without much issues. Again, when we actually spoke about data frames, we spoke about Spark SQL, and there are two contexts. One is Spark native context, and other one is Hive context. Hive context can be used to query tables which are created in Hive, and if you don't have pre-created tables, if you want to still process the data in the form of writing SQL type of queries, you can do that using Spark native context, but you have to create case classes, and you have to apply the case class on the data as part of map function, and then you have to register it as temp table, and then only you will be able to write SQL. Okay, but in both the scenarios, you should be able to use the same type of syntax for most of the queries. However, there are certain scenarios where the query which runs in Hive context might not run in Spark native context. So we'll see all those things, but first let us understand the Hive QL. Okay, and then we'll take it from there. So that being said, you can go to language manual of Hive, and okay, let me get to it like this. You select Hive documentation, click on Hive manual, and here you can see select. You can choose this one to get the syntax of the select query. Okay, so if you know this one, you are good to go. Okay, so but it does not include joins. Probably somewhere else it might have given joins. We'll try to cover each and every aspect of this, and also we'll try to see the joins which are not explicitly specified here. Okay, so when it comes to writing select queries, This is the typical syntax. You give select all, which is default, and again you can give expression. As part of select expression, you can give a simple column name, or you can apply a user-defined function on the column, and then you can. That's why they call it a select expression. Either you can give simple column or you can give a user-defined function, and then from you have to give the table name. That is the simplest form of writing any query. Okay. So if you are familiar with Oracle, you might have heard about something called dual. Okay, what is dual? Dual is nothing but a view which will have only one record in it. And if you want to test any functions and all those things, you typically say select function and function parameters from dual, which will only retrieve one record, and you can easily test the function. The reason why Oracle have created that dual view is because Oracle SQL engine expects from clause when you type a query. You have to say from, and you have to give some valid table name or view name. Only then the query is complete. So select clause and from clause are mandatory for any simple query in Oracle. Whereas in other databases like MySQL, Postgres, from where Hive is greatly influenced, you don't need to give from clause. Okay, so let me show you here. Okay, so here if you just select one semicolon, it will return one. Whereas in Oracle, you have to say select one from dual. Okay. Similarly, if you want to test select substring function, and then if you want to get only first 5 characters, you can just say like this: select, give the function name, give the all the parameters as per the syntax, and then type semicolon, and you will get the results. Okay. So this is the simplest form of query in Hive. It follows MySQL. MySQL also behaves similar manner. And then typically when you try to query from a table, you have to give the from clause. So here, if I switch to the database, I think I have Wavelabs DG. Let me use that one. Show tables. There are all these tables. And if I want to just select from table categories, I just have to say select star from categories, and it will retrieve all the rows. In this case, it has 58. If you just want to limit, you can just say select star from categories, limit 10, and it will only fetch 10 records. Whereas in, if you are familiar with Oracle, there is a field called row num. You have to use that row num and less than or equal to 10 to get the first 10 records. Whereas in most of the other databases, either you use top. In MS SQL, Microsoft SQL Server, you have to use top. In MySQL, Postgres, and all, you have to use limit to get the n number of records. Okay, it is similar to take in Spark. And then if you want to filter the data, you use where condition. Okay, and as part of the where condition, you should know the BODMAS rule about how it will evaluate. I hope everyone is familiar with it. Brackets. What is off? Yeah. Yeah. What is B then?
Brackets.
Brackets
of division multiplication.
Okay. Brackets of division, multiplication, addition and subtraction. Okay. So you should know that rule, and also when it comes to applying Boolean operations, you should know how the things will be evaluated. I will give few examples here, and then we will see. Okay, so here, let's take the example of orders. Okay, So I'm giving the example of where clause. So if you just want to get all the completed orders, you just have to say select star from. You have to use where clause to apply any filter. So in this case, if I want to just get complete orders, where order status equal to complete, it will get all the rows. If you just want to preview, you can just say limit 10. Okay. Similarly, if you want to check for both complete as well as closed orders, means either complete or closed orders. I should not say both complete and closed. At a given point in time, no order will be in both complete and closed state. The terminology is very, very important. So if you want to get all the orders where the status is either complete or closed. So one way of doing it is, this is not the right way of doing it, but it is still valid way of accepted way of doing it, is you can use OR and then say order status equal to closed, and then it will give both completed as well as closed orders, or all the orders which are either in complete state or closed state. Okay, now let's say there are 15 different types of statuses, and if you want to check if the order status falls in any 5 of those categories, given 5 of those categories, if you try to type with OR clause like this, order status equal to complete, or order status equal to closed, or blah 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 5 times, it takes a lot of real estate, a lot of typing, and also as you tend to type more, there is a probability of mistakes. It compromises the readability of your query. For that reason, in query SQL, they provide a special clause called in clause. Okay, so instead of saying order status equal to complete or order status equal to closed, we can say order status in complete, comma, closed. At the time of execution, it actually implements the same logic similar to order status equal to complete or order status equal to closed. Okay, and then hit enter, you will get the same results. Okay, now if you want to check order status complete or closed, and only for a particular month. For example, I want to get all the orders either in complete or closed state for the month of 2013 December. Okay, so here we have to use a AND operator. So these are all OR and AND are Boolean operators. So in is a special type of OR. Okay, and if you want to write like order status equal to complete or order status equal to closed, and order date, whatever condition it is, if you write like this, a lot of people in the initial stage of their career, they tend to make these mistakes. Okay, order status equal to complete or order status equal to closed, and order date equal to or like. So if you want to just get a given month, which is 2013 December, instead of using equal and substring function, you can say like. Like is a special operator in SQL. Most of the RDBMS support this. You can give 2017-12 because we are looking for 2013 December percentage. Okay, and then you can say limit 10. So this query, even though it sounds right, it is not. It does not give the correct results. So to validate that, what I will do is, if you see it only gave all the completed orders, and also date is not 2013 December. It is giving 2013 July. Why? Why? Because it will check order state. So when you use OR, if the first condition returns true, it will return the result immediately. Okay. When it comes to end, it has to satisfy all the other all the conditions. Okay. So to fix this problem, what you have to do is either you can use in the way I have shown, or here we are trying to get all the orders with either status complete or closed and order. Let me hit enter. And order date like 2013 December. Now you see you are only getting data from 2013 December, but the status are either closed or complete. This is very important thing to define the scope of these Boolean operators accurately. Okay, so first you need to interpret the requirement properly. Here the requirement is give me all the orders if order status is either in complete or closed state for the month of order date for the month of December 2013. Okay, so as he is asking for order status in complete or closed state, you just put those two things in close circular brackets, which will make sure. So what the way it will evaluate is first it will go through this. Okay, if any one of these things are true, then it will also apply the second condition. If you don't have these brackets, if it is true, immediately it will start giving the result. If it is false, then it will check for the second one. Okay, again it will start giving all the but when it comes to the second one, after that there's the end. So what it will do, once it goes to the second, as the next one is the end, it will try to check the this combination. So the way it will be evaluated is it will give all the orders where status is complete or the orders which are closed in the month of 2013 December. So it will give all the complete orders plus orders which are closed in December 2013. Okay, which is not correct result as per our requirement. In some cases, you have to get like that also. Okay, so you have to be extremely careful while understanding the requirement. A lot of people make mistakes with this. Okay, and the reason why I'm emphasizing is even though you are pretty comfortable with SQL, there is a chance that you overlook at the time of the certification and you might make the mistake, and you don't know whether you are doing right or not until you see the result. Okay, so this one you have to pay special attention and make sure that you write the query, especially with when they're asking with Boolean operators on multiple columns. Okay, the correct way of doing is select star from orders where order status incomplete, comma closed, and order date. That is the better way of doing than this. Okay, and like is a special operator, as I have explained, where you can pass percentage at the end, and yeah, it is called as pattern matching, and it will get you the results if it starts with this value. Okay, if you want to get based upon ending with a particular thing, you can just say percentage and then give the string. If you want to check for contains, you have to say percentage string percentage. Okay, so like that you can use like effectively. Okay, and now let us get to the other clauses such as group by, order by, cluster by, etc. So again, as I have explained to you earlier, whenever you write a query, you do at a higher level 4 or 5 things. One, either you filter out the data. Two, you apply the transformations on the data for cleansing or standardization, whatever reason it is. 3, you aggregate the results. And if these things require joining multiple data sets as part of the technical implementation, you have to join the data sets. These are few things which you will do with SQL. Okay, so now we have orders table, order items table, which you have been seeing for quite some time. So next thing is we will try to identify how to apply the transformations. Okay, so when it comes to transformation, there are 2 types of transformation. One is row level transformation, where individual rows will be passed to, and you apply certain transformation and get equal number of records post the transformation. If you have to filter anything, you just have to use where clause. Okay, so let us say that we want to extract year and month for each of the date. Okay, so how will we do? So in this case, I want to get the order ID, order date, order customer ID, order status, as well as the order month for complete or closed orders. That's my requirement. So first you need to understand what needs to be applied in where clause, what needs to be applied in self clause, etc. In where clause, you will have this condition: order status equal to complete or order status equal to closed. In the select clause, so whenever you have to do the transformations, you have to apply certain functions in select clause. So in this case, I want to get all the 4 fields: order ID, order date, order customer ID, order status, and then I want to get the year and month from each of the date. So typically, when you have to do the transformation, you, in most of the cases, you have to apply some expression. Expression can be UDF, or it can be something like case statement. Okay, so where when you have to do UDF, for example, in this case, I want to extract year and month from the date. Okay, for that there are a bunch of UDFs. We have to identify which UDF should be used. So there is a UDF called substring. It is similar to any traditional RDBMS substring functionality. Now it is too hot. Right? It suddenly becomes very hot. Okay, substring, order date 1,7. Okay, but if you can typecast to numeric value, you should consider that. Typically, we will see that how to do that in a moment. In this case, we will just get a month for each date. What is the month for each date? It's not just the month. Year and month constitutes the month of a given date. Okay, so in this case, we will get first 7 characters from the order date, and I'm naming it as order month. In Hive, make sure you always do the aliases for the expressions. Otherwise, you will see some negative effects, which is very tough to troubleshoot later. Okay, always give aliases whenever you give expression. And then from orders, we are only interested in complete and closed orders. So order status in complete, closed. Should have set limit 10. Okay, this is the one. Limit 10. Okay, now you see we are getting the year and month for each date. But from this, I just I want to convert this into number, which means I have to extract the year and then extract the month, concatenate those two things, and apply cast function to convert it into integer. So to get the list of functions, you can say show functions. Most of the functions are similar to traditional RDBMS SQL functions. You can also integrate third-party functions easily. You just have to get the jar and then issue two commands, add jars and pass the jar file, and then you have to say create temporary function. If you need additional functions, you need to implement certain APIs from using Java, and then you have to develop or extend the functionality, and you have to build the jars file. And as you integrate the third-party jars, you have to take care with your jars also. Anyway, that I will not be covering because it's out of the scope with respect to certification. But if you are interested, you can actually go to IT University channel and check for Hive UDFs, and there are few videos on that. Okay, so here one of the important set of functions is primarily to get or to work with the dates. Okay, so you can say select current underscore date and hit enter. It will give the today's date. If you want to get the timestamp also, you just have to say current timestamp. It will give date as well as time up to milliseconds. Okay, from here, if you want to get year, I think you can say year, current, date or timestamp. It has become slow. I hope people who are online can hear me clearly, because I'm running the show on Wi-Fi, and it can cause some glitches in between. So if that is the case, let me know. Similarly, if you want to get the month, so in this case, it will only get the month. It will not get YYYY-MM. It will only get the month. Okay, so it got the month, which is 4. And then you can say day, and it will get the date, today's day. Okay, and also if you say show functions and hit enter, there are a few more functions like date add. If you want to add dates, so many days to the date and get the date, you can use date add. Date format, select date. If you want to get the usage of it, you just have to say describe function date underscore format. In most of the cases, it will not give the usage. Documentation is not complete. So here it says converted date timestamp string to a value of string in the format specified. So if you say, it's like two string function in Oracle. If you say to underscore string, and if you give the date, and if you give the format, date will be converted to string of the format you have passed. So in this case, if you say date format current date, and then give the format, I think it is %y, %m, Okay, I know the problem. It would be like this. Yeah. Okay. And here we have to give capital M, I guess. Okay. Hmm? Yeah. Only M. This is in SQL, Oracle SQL it is different. This follows MySQL way. Okay, in Oracle SQL you say if you want to give if you want to get 4-digit number, you have to say y. And if you want to get to two-digit month, you can say mm. If you want to get three character month, you can say mon. If you want to get to the complete month, you have to say month. But here it's a little bit different. Okay, if we give mm, yeah, is giving two-digit month. I think if you give it will give three character month. If you say it will give the complete month. It's different from Oracle to here. So you need to be very careful. If you are very experienced with Oracle, it can cause some confusion. Okay. If you just give small y, it will give two-digit. Small y also giving 4-digit. Okay. Okay. So if you give two y's, it is giving two-digit number. If you give one y or four y's, it is giving 4-digit number. With the three also, it is giving. Anyway, that's fine. So now if I want to get the integer part of the date, okay, but our order date is actually of type string. It is not of type date. And date format, if you see the help on the date format, it says it converts a date, timestamp or string. It also accepts string. Okay, so we can say select date format order date, comma y or mm from orders limit 10. You see now we got the 6-digit string. This is a 6-character string. This is still a string. Substring date format always returns string. Now to cast it into number, you have to use cast function. Okay, so cast function syntax will look like this. You have to say cast and give the expression. After that, you have to say as the data type. Okay, and hit enter. Now this is actually number. Otherwise earlier it was string. So if you want to represent as number to our original query, what is our original query? This is our original query. Order status. Here we can say date format IMN, then cast as int.
Instead of doing all the 4 headings, why can't you like start?
Yeah, you can do star.
Instead of mentioning all.
You can do star. But I think you have to give alias name and then alias dot star. Otherwise, if you just say star comma, it might not work. Okay. but typically I don't use star. Even in application development, it's not good practice to use star. Okay, and then limit 10. Now we got the year and month in YYYY format with by after casting it as number. Okay, so I will give some time here. Review this, run the show functions command, and review those things. It is mostly similar to the traditional SQL, and you have to practice these things quite a bit. Okay, substring and substr are same. It takes a string and give a substring out of it. And date functions are very important. And then we will improvise on this query and try to define some problem statements and start implementing those things. Okay, I will give, now it's 3:13, I will give 6-7 minutes up to 3:20. Go through the list of functions. You can also practice, and if you have any questions, you can let me know.
So all these functions for SQL,
What's that?
all the functions which listed here,
Yeah,
part of SQL.
HiveQL, yeah.
Some
What is that?
some unknown functions. need to just
Yeah, some things are like XPath and all are primarily for XML, and then there are some things like entile, ngrams, etc. They are related to machine learning. Okay, yeah. So you have means they are not very important for the certification purpose, but over a period of time you should know what functions you have. And few functions that are important are this from underscore Unix timestamp, from UTC timestamp, so from Unix time. So from Unix time is it is actually the number of second from January 1st, 1970 or something. Okay, that is the Unix time, which is represented by number starting from January 1st, 1970 or some other date. So at times in data warehousing, right, for the performance reasons, we store it's a timestamp. Uh, it's not date alone. It's complete timestamp. It's the number of seconds. If you say current, if you try to get if you run date command in Unix, whatever number it gives, it is that second from 1970 January 1st. So at times we tend to use that to store the date or a timestamp in database. So if you want to convert that numeric value to actual date, you have to use from Unix time or there are few commands. Let me show you. So now if I say select from underscore Unix time, okay, I think it takes few parameters to describe. I think I have to give brackets. Yeah. Now can describe from underscore Unix time. Let me see. Describe function from underscore Unix time. Now we have to pass Unix time and format. Okay. To convert into Unix time, we have to use to underscore Unix time. Okay. So if I say select to underscore Unix time and current date. Let me describe function to Unix time. We have to give the format also, I guess. Okay, let me see. To underscore Unix underscore timestamp. That is the function. So this is the function. To underscore Unix underscore timestamp. Okay, it takes date and optional pattern parameter. So we can say select to underscore Unix timestamp current timestamp. Okay, so that is the number, and now you can use this and say select from underscore Unix time, and you have to give the format. Let's say Y M D and I think small d. Yeah. So capital D will give the I think it's the day of the year. So today is April 3rd. Till March 31st, it's 90 days. As it is 93rd day, it has given 93 when I give capital D. With small d, it will give day of the month. Okay, so this is how you can convert Unix timestamp to actual timestamp and actual timestamp to Unix timestamp. Unix timestamp. Okay, you can also say mmdb. And also I think you can get the time by saying %h just h, and then m for minutes. Okay, now it's 550 for seconds, I think. Yes. Okay, so that is the time. If you go to if you see, it's 553 now, and that's what we got. So this is how you can get the time also from the so small h is for hours, small m is for minutes, and s is for seconds. Okay, so let me see if there are any other important functions which I need to cover. So again, if you look into these functions, some are row level functions, which means one row will be passed as input and other one value will be passed as input and other value you will get as output. On top of it, there are some aggregation functions, some average, min, max, etc. Okay, so it is very easy to identify what are the aggregate functions and what are the typical functions. Okay, so when it comes to aggregations, counting the number of records is kind of aggregation. So if you want to get the number of rows from orders, you can say select count of one from orders and hit enter. Okay, so this is how you can get the count of orders. But when you use aggregate functions, and if you so this is we are trying to get the count of all the orders. Now, if you want to get the count of orders by status, so if you look into the orders table, there are 4 columns: order ID, order date, order customer ID, and order status. Okay, and if you say select, if you just want to get distinct of any field, you can just say select distinct column name, order status from orders. I think there are 7 unique values under order status. Actually 9. And now if you want to get the number of orders within each state, so let's say I just want to go through all my orders and see how many orders are there in each type of state. Okay, in that scenario, you have to use the next clause. If you go to the syntax called group by. Okay, so here you have to say select order status count of 1 from orders group by order status. So when you use group by, or when you not group by, actually when you use aggregation field, if one of the field is aggregation in the select clause, so this is aggregated expression which will actually aggregate the data. If you have any expression which will aggregate the data in select clause, either you have to have all the expressions as aggregators as part of the select clause, or you have to use group by, and all the non-aggregated expressions should be included as part of the group by. Only then it will work. So in this case, count of one is a aggregated expression, aggregator, which will aggregate the data, and order status is a typical column. Okay, and if you have few other fields, for example, I want to get number of orders by status for each date, then you have to say order date and order status. In that case, in group by clause also you have to use order date and order status. Okay, it is the feature which you have to follow certain rules as while using this feature. So if any one of the field in the select clause is an aggregating expression, either all the fields has to be aggregating expressions or all the non-aggregating expressions should be part of group by clause. Okay, now we can say our original requirement is to get only complete and closed orders. We will see that. That's fine. That is different. So now you see you got the data for each order status. We got the count. Okay. Now if you want to only display the order status and count if the count is greater than let's say 5,000. Okay, so in that case there is another special clause which is not highlighted as part of this syntax. It is called as having. Okay, so having count of 1 greater than or equal to 5,000. Okay, typically in the having clause we will have the expression which is aggregating the data. Okay, we cannot use where condition. Where condition is to filter out the individual records. Here, after aggregating, if you want to filter out, you can use having clause, or you have to nest the query into another query and then use the where condition. This is the better way of doing and dealing with it. And also here I want to sort the data by the second field. Okay, now if I say count of 1 DESC, in traditional RDBMS it will work. Here it will give some error saying missing by, at, count, etc. Okay, which is misleading error. The way it will do, you have to fix this is give a field count per status. You can give any name and then group by. Okay, it was failing for order by clause. I just have order, not I don't have by. So let me give order by here and hit enter. It says not yet supported place for UDAF count. So here it is not highlighting where it is failing. So this, okay, now it is actually showing line. Earlier it used to not they were not reporting the line. At least now they are reporting the line, and also they are actually reporting the column also. So here it is failing. So we have to use the alias when it comes to order by. Now it is running. And if you closely observe, for each query when you run, it says total jobs equal to, and in this case it's giving 2. Earlier it was giving 1. Whenever map reduced jobs are generating, first thing it will report is how many number of map reduced jobs will be executing for a given query. From that, what we need to understand is a single Hive query can be implemented, means will be implemented internally using multiple map reduce jobs. Okay, and they are called as chained map reduce jobs. There will be multiple map reduce jobs to support a single query. It is 0 to n. So if you just write simple query with limit 10, kind of stuff, it will not even use MapReduce. Very few scenarios it will not use MapReduce. Now you see, we got all the we got the order status and count which are greater than 500, and also data is sorted in descending order by order status. Did I use? Yeah. So when you use order by clause, if you say this DESC, it will sort the data in descending order. By default, it will sort the data in ascending order. So having clause is also very important, which is not covered as part of the documentation. Now, let me take this call. Okay, if we go back to the previous example, the previous what we are trying to what we have done. Let me get back to that query. That's fine. I will just scroll up and get it. That is better. And I don't, probably there might be a command to get the history. I do not remember. Yeah. Okay, now if we go back to this query, okay, here let us say I want to get the number of complete and closed orders by month. Okay, so how can I do that? I just have to delete this thing. I'm just trying to get number of completed or closed orders, the orders which are in either completed state or closed state by month. Okay, and then I want to get count of those. Hmm? Yeah, we have to use group by order count, group by. We just have to use either in this case either you can use alias or you can use this cast function. Whereas in order by clause you cannot use the function. You just have to use alias. Okay, so in this case I'm using cast function, and then order by order count DESC. It is working. Yes, it is working. Okay, so he's asking how it will behave in Spark. So let us validate in Spark also. Okay, first we need to launch Spark shell. I'm launching it in yarn mode, and then conf spark.ui.port equal to 54321. Okay, there are some memory related issues on this. Okay, there are so many people. Let me clean up some of the sessions. 565 CD collapse. Yes, yes. A lot of active sessions. Huh? Let me check. Yes, I can. Yes. Not on the old sessions only. Do not clean. Tab. Okay, let me kill Richard 10 minutes old. It is not working. No, it is not working. There will be these many sessions within. Anyway, let me try now. Oh, it is still not coming up. Anyway, let me go on to some other node. Okay, now I am launching Spark. You will not be able to launch. I need to restart. I think it is running. It is out of memory, so I have to fix it. I will restart. Let me restart it. I'm restarting the server. Okay, so then I have to. Okay, now I'm launching Spark. Shell master. Done. Can you just discuss if there are many complaints about
Only
Ambari?
Spark, there was only one issue for Spark.
Okay. I need to add one more gateway node.
Sessions are
Hmm?
sessions are filled.
Yeah, now because I restarted. But this should not take so much time on N01. Let us see.
Oh, it is down. For 6 hours it is down.
Hmm?
Latest it is 100. If it's scroll down, it is coming. Issues are
Yeah?
from 6 hours.
Okay. Good. Why this is not starting from N01? Let me fix the Ambari. Let me launch in normal mode. Okay, I will cover Spark later. Let us proceed. Okay, so we have seen how to get the order count for each month. Okay, now if you look into the data and if you want to get revenue, so let us define a problem statement and get into joins also. Okay, so when it comes to joins, joins are similar to set operations, but only difference between set operations and join operations are, in case of join, only one field will be common between the two datasets, which is primary key in one and foreign key in other. That is the typical scenario. There are exceptions for that, but that is the typical scenario. Whereas if you want to use set operations such as union, intersection, minus, etc., then both the data sets should exactly have the similar structure. The columns can be different, but the data types has to be similar. Otherwise, you will run into issues. So we'll see the difference. We will see both the cases when we should use joins and when we should use uh, the union operation. So let us define a problem statement. Not started. Just give me a moment, okay? I need to fix this issue. Most probably, sometimes the shutdown will not happen gracefully, and it might be hanging on something, which will cause the server not to reboot. I need to fix that, and then I will come back to the agenda. Oh my God.
Because now you are using it.
Okay, that's fine.
Running applications.
That's fine. That is normal. But it will take some time. Yeah. Okay. So here service. How it is working. We're almost there. Okay, so let me finish this thing. Submit local first. Just take some time to pick up. Or somebody should come up. So now the issue is fixed. Thank you for your patience. Now let us go here and then let me run this partial command. So Abhishek was asking whether it will create multiple Spark jobs. We will see. And also when you actually run in Spark context, instead of running in MapReduce as a Hive execution engine, it will actually run as part as Spark executors. It will not run in the form of MapReduce. But to validate your query, whether you are using correct table name, correct column names, etc., it has to connect to the Hive metastore. So to generate the Spark-based code to run the query, internally it uses Hive metastore. Okay, so now SQL context is the variable name is SQL context. To get the data type, you just say SQL context, and it is of type Hive context. And now you can say SQL context dot SQL, okay, and use WLabs DG. That is the database I want to use. Now I ran this query in Hive. Now I'm trying to run it in Spark. So how will you run? You will say SQL context dot SQL. Okay, because it's in multiple lines, it is failing. So this is how it will look like. Let me put it in single line. Or you have to use plus as the concatenator. In this case, I am just making it simple by using SQL context dot SQL, and I will be passing this entire query without semicolon in the double quotes SQL context dot SQL. Okay, and then this will actually generate a data frame. So you can actually apply collect for each interval. So it will start running the query. Okay, and you can see it actually used 200 tasks to run the query. We can change it by saying by using spark.sql.shuffle.partitions. You can set it to lower value, and you can use lesser number of partitions. Now to validate how it ran, you can go to Ambari. So, yeah, not Ambari, Resource Manager Web Interface. And this is the query I ran on the Spark shell. I can select this one. And so this actually, see, you can see that it actually ran in the form of two queries, two Spark jobs. One query resolved into two Spark jobs. And if you look at the first one, you can see it is doing Hive table scan and applying filter, project, tungsten aggregate, tungsten exchange. So tungsten aggregate, tungsten exchange are related to data frames. Okay. And then finally, as part of the second job, it is actually sorting the data. Okay, because we have used order by. So depending upon the complexity of the query, it will run in as many number of Spark jobs or Hive or MapReduce jobs, Hadoop MapReduce jobs it requires to implement the logic. Okay, in most of the Hive queries will run in Spark using Hive context. But some of the queries, if you try to simulate the same thing using Spark native context by creating case classes and all, as part of 1.6.2, Spark SQL is a little bit behind than Hive SQL. or SQL in Hive context. So some of the queries, especially the ones with windowing functions, will not work in native context. So we will see that. Those differences are very important to understand, and I will cover that as we proceed. Okay. Now comes the joining the data. For that, joining our union operation, set operations. So let us define the problem statement. Okay, the problem statement is get me the revenue for each day. So for only complete and closed orders. So if you go to the data model,
Smart history server. Smart history server. That is down. Maybe it will restart.
yeah. So hosts. Okay, thank you. Now it will come up. Okay, so the requirement is to get the revenue for each day for only complete and closed orders. So if you go to orders, it has only order status and order date. It does not have revenue. So we cannot use orders itself to generate the revenue. Instead, we have to identify the table. The table which will give us the revenue is order items, and order items only have the order item subtotal which is required by our requirement. The other things are order status and order date. But in this scenario, because we are trying to get fields of different types, a number of fields are also different between orders and as well as order items, we need to use join operation. The only common key here is order ID. Order ID in order table and order ID in order items table. So using that, we will join and we can get the data required from orders and the data required for order items for subsequent processing. So in this case, we can say select o.order date, oi dot sum of oi dot order item subtotal revenue per day from orders or join order items. So when it comes to joins, you can use either Oracle way of join, Oracle's native way of join, which is you can actually say from orders O, comma order items OI. O and OI are just aliases to the table names. It is not mandatory to give. But in some cases, if the column names are same between the two, if you don't give aliases, you have to give the complete table name dot column name. So for that reason, we typically give the aliases so that we limit the typing by joining the same field between the two tables or referring the field which is present in multiple tables. We can say where from orders O, order items OI, where O dot order ID equal to OI dot order item order ID group by O dot order date order by O dot order date. Hit enter. Okay, it is running in test engine. Okay, I'm on NN01. That's why it is running in test engine. Okay, let me use this. Starting to launch local task to process map join. Okay. Why it is running so slow? Okay, let me kill this. Okay, I will use the name node itself. Hive. Are there too many issues like in Ambali?
I think I'm working with it. Helps you feel about that memory can
Why it is using so much of 840, 470. Okay. It is taking too much of time. It should not take such a long time. I don't know why. Correct. Let me disable the okay. So I'm disabling this one so that it does not do the map side join. I will cover what is map side join and all in a moment. Yeah, now it is working. It is running. Okay, so this is the example of using Oracle style of join. If you want to use ASCII join is recommended because it's much more readable and also it differentiates between the join clause and the where clause. Okay, in this case, if you see join condition is applied using where condition. Whereas if you use ASCII join, which is now the standard, we say from orders join order items on the join condition, and then if you want to do additional filtering, you use where clause. Okay, now it runs successfully. Okay, I know why it is taking too much time. One of the table does not have the data, probably order items. Select star from order items, limit 10. It's there. I think orders is the one which does not have the data. Yeah. So I have to go to W labs DB. That's why it was also hanging in earlier. So map side join, there was issue when one of the table is empty. Now I got the problem. Now let me set it to true. And now let me run this query. See, it completely muted. Probably it is a bug. Okay, now we'll get the data. And similarly, if you want to uh, if you want to get all the I'm trying to figure out the scenario for to use the union operation. Okay, let's say you want to get all the common categories that are being sold in a given month from uh, yeah. So if you look at order items, right? Order items limit 10. Okay. So in this you have order ID. This is order item order ID. So this is order item ID. This is order ID. This is product ID. Okay. And let's say you want to get the category name which is being sold in two subsequent months. Pick up any two subsequent months and let us say I want to get the categories which are sold in both the months. Okay, so how it will look like, that is the use case for union. So we have to get all the categories which are sold for the month of, let's say, December and November are the 2 months which we are looking into. So we want to get all the categories for the month of November. We want to get all the categories for the month of December. And to get the common products between the two, we have to use intersect. Okay, to get all the categories sold between the two, either we can use union, or you can just say select distinct category ID, then the join using one query you can get the result. And if you want to get categories which are sold in 1 month but not in the other month, you have to use minus. So if you draw Venn diagram, it will be very easy to understand set operations. So let me let us pick this one. So if let's say A is the categories sold in November and B is categories sold in December. Okay, if I want to get this part where the categories sold in both the months, we have to use intersection. If I want to get this part where the categories that are sold only in November but not in December, then it is called as A minus B. Okay, and if you want to get all categories sold in all the categories sold in either of the months, then it's A union B. Okay, so for these purposes it supports union, intersect, and minus. So let's try to write a simple query for that. So in this case, it's combination of join as well as union operations, because we are trying to get categories that are sold in November and also categories that are sold in December as two different sets, and then we want to use the set operations. So where is the categories? Categories is in the table called products. Okay, order items only have products. So first let us get the category name from categories. And if you want to use the ASCII join, you just have to say join products on category ID equal to product category ID, that is the field name. Join order items on product ID equal to order item product ID. Okay, and I just want to say limit 10 to get first 10 records, and we have to use distinct in this case because We don't want to get duplicates. Okay, while it is running, let me copy this query to Sublime so that we can quickly develop. Okay. Here I can set distinct category name. So to get the ones which are sold in November alone, I have to use the where condition also. Okay. So for that, we have to join with orders on order ID equal to order item order ID, where order date like 2013 November. Okay. And if I want to get this minus B, which is for 2013 December, we can run query like this, which will give the categories which are sold only in November but not in December. Enter. Oh, the 1 minute. Yeah, that's correct. I think I have to give something like this, correct? Okay. Okay. And then let us see whether it will work or not. That's not the one. Let me get the syntax for I minus. Okay, there is no minus operator in Hive, only let us see whether they have union or intersection also. Intersect. If you need minus, I think you have to implement join only. So intersect is also not there. Let us see union. Okay, it was there. Never mind. Only union is there. Intersect and minus are not there. Okay. I think for intersect and minus you can use joins, but it is a little bit complicated. Okay. So and then full outer join and left outer join. If you want to, I will explain the left outer join and full outer join also in a moment. While it is running, let us define the problem statement for left outer join or right outer join. So we have orders table and we have order items table. There can be some orders which are only in orders. Orders is a parent table and order items is a child table. Some of the orders might not have the order items. So let us say we want to get number of orders by month where there are no associated order items. Okay. So the way you can do is, first we have to validate whether there are any such kind of orders. That you can say select count of 1 from orders. In orders, order ID is primary key. So whatever count it will give the number of order IDs. If we just say select count of 1 from orders. And to get the number of order items that present in order items, what we have to do, we have to say select count of distinct order item order ID from order items. It will give the number of order item order IDs that are present in order items. Select count of distinct order item order ID from order items. So there are 57,431. That means almost 11,000 orders does not have order items. Okay, so let us try to get by status rather than month. Okay, to see what are those that are missing. So how you will do? You will say select order status, comma count of one from orders. So if you, in this case, we are trying to left outer join orders to order items. Okay, because we are trying to identify those orders that are only present in orders. If you type orders on the right side, you have to say order items right outer join orders. If you have orders on the left, you will say orders left outer join order items. Right outer join is nothing but
Putting the table.
swapping the tables positions, and instead of using left, using right. That's it. Okay, orders left outer join. The same thing if you want to write it in Oracle notation, you have to say from orders, comma order items, and where order ID equal to, okay, you have to say plus. So here, if it is left outer join, you have to put plus on the right side. If it is right outer join, you have to put plus on the left side. Okay. When I say order ID is from orders table, so we are trying to left outer join orders with order items. Hence, we have to put plus on the right side. If you have order item order ID on the left side in the where clause, then you have to put plus equal to order item. Sorry, order ID. Order item order ID group by order status. What is that?
Is it supporting that operator?
I think so. Probably it might not be. Okay, I know the problem. So the way you should write it is like this. Actually, you have to put plus, not around equal. You have to put plus here. Let us see if it works. Otherwise, we'll try to use ASCII join. Earlier, they were not supporting this Oracle way of joins. Only in the recent versions, they are doing it. Okay, group by operation. So it is complaining that group by. Where we have. Okay, I think it only support plain join. Left outer join, I think is not supported with plus. Okay, so let us now use the ASCII join from orders. Left outer join order items on order ID equal to order item order ID group by order status. Now it is running. Okay, so far we have covered group by clause, having clause, little bit of sorting the data, and also we have covered set operations as well as join operations. So now we got the okay. Now this does not give the correct result. If you see, cancelled, it is giving 3,753, closed 19,923. But in our case, it the overall number itself is 11,000. So what we have to do is we have to filter out the data which are present in both the tables. In the previous query, I haven't done that. That's why it is failing. So orders left outer join on, and then you can say where. Okay. So we are trying to get data which is only present in left table but not in the right table. So which is orders but not in order items. So we have to pick one of the fields in order items and see if it is null. Only those things we want to consider. And when you pick, you should only pick primary key field. You should not pick the field which is nullable. It will generate incorrect results. So in this case, the primary key field is order item ID is null. When it will be null? Only if there is no corresponding record in order items, but there is one in orders. Okay. Then we can say group by order status. Now you got the number. Okay, and if you add these things, it will be approximately 5,000, 6,000, 7,000, approximately 10,000. So which is more accurate. Okay, and sometimes you might have data in order on. So in this case, for each and every order item, there will be corresponding order ID because there is a primary key foreign key relationship on the source data. In some cases, there could be a scenario where you have some records which are present in one table, but not present in the other table, and there could be some records which are present in the other table, but not in the first table. And if you want to get all the data which is present in both the tables plus the data which is only present in first table and also the data which is present in the second table with nulls in the counterpart. In that case, we can use something called full outer join. Full outer join is nothing but A left outer join B and union A right outer join B or B left outer join A. Okay, so that is about full outer join. And now you need to understand certain clauses which are specific to Hive. So all these things, whatever we have covered so far, are already present in traditional SQL also. But there are some additional clauses which are specific to Hive, which you won't see in any traditional database. However, I will cover those things tomorrow. It's very, very important. But before we wrap up today, let us see few important differences. Okay, so when you actually give a query in traditional RDBMS, it is quite common that we use something called nested queries. So nested queries are supported here also. Okay, let's say I want to get all the orders where order ID that is present in order items table. Typically we do join, but you can also use in clause and then you can actually give a query results as part of the in clause. So here we can say order ID from order item order ID from order items, and let us do limit 10. and hit enter. So this passing the subquery as part of the in clause is only supported in the recent versions. In the earlier versions, it was not supported. Only hard-coded values were supported as part of the in clause. And to write similar queries, there is also support to something called exists. So in traditional RDBMS, you can also say select star from orders where exists. Okay, select one from order items where order ID equal to order item order ID. So you can also write the same query like this to get whatever orders that are present in whatever IDs that are present in orders, um, uh, as well as in order items. Either you can use join or you can use in and pass the subquery, or you can also use exists. Out of the three, you should only use join. There are certain scenarios where you instead of join you can use in clause or exist clause, but for this scenario you should use only join. But just to show the syntax, I'm picking up this use case. But exists is not supported as part of the exists, and nested queries are not supported. Uh, okay, invalid subquery expression order item already for exists or not exists operator subquery must be correlated. Oh, earlier they used to not support at all. Now I think they are actually supporting. Let me see. So, they have changed quite a bit.
And water items. Why?
Yeah. And it is working. Earlier it used to not to work, both in condition with the query as well as exists. It used to not to work, and also there are certain restrictions here. If you the query which I have written earlier without giving aliases, this should have worked in databases like Oracle, but in Hive it is actually expecting uh, um, the query expressions to have the means the table should have the aliases for them. When I use aliases, it worked. Okay, similarly, if you want to run a subquery, this is another. Let me take this example: select star from uh, select star from orders limit 10. This is also valid query in traditional databases, but here it will work, but you always have to give the alias. If I give alias, it will work. Okay. And also, I will extend a little bit today's class, 10 to 15 minutes, and I will cover something called analytic functions, which is very important. And as part of the syllabus, especially for CCA data analyst, they are talking about those analytics functions or windowing functions. So what is analytic functions or windowing functions? Typically, they will be applied in the select clause, and it will start with a function such as rank, row number, sum on particular field, etc. And then once you give that, you say over partition by. Whenever you try to use rank uh, on top of partition by, it will also take uh, something called order by. Partition by and order by. You can give different field for partition by. You can give different field for order by. So this syntax of rank over blah 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 is called as windowing functions or analytic functions. When they are applicable, when should we use? Okay, let's take simple use case. Okay, earlier we have used this query, right? Let me take another example. So we have the products table. Okay, select star from products. Okay, it has approximately 1345 records. Okay, and we want to so the first field of products is product ID. Second field is product category ID. So within each product category ID, within each product category, I want to get um, rank of products in the order of in the descending order of price. That is the problem statement. And also I want to get all the other all the other details for each product. Okay. So how will we get it? We can say select. So if you use, you can use this simple query: select stars on products, order by product category ID. Okay, and then product price descending. Okay, you will get from within each product category ID, you will get the prices in descending order. The first one is the first rank, second one will be the second rank, etc. But if you want to get only top three within each category, you cannot use order by clause like this. Okay, with group by there are multiple restrictions. If you have to get all the details when you do the group by, you have to do the first you need to get the data sorted in descending order, and you have to do the self join just to get the top product itself. It is complicated. If you want to get top three products, you have to self join the query multiple times, and also it is not very efficient.
That
The
is also wrong. Limit if you give this query, if you give limit 3, that is also wrong.
limit 3 will give only first record from the entire data set. That's what it will give, only 3 records. In this case, I want to get top 3 from each category. So you cannot use limit. One way of doing it in the early days when analytic functions are not there to get top 3 products within each category is by self-joining the table 3 times. And it's very complicated. And also performance-wise also it is very bad. That's when the Oracle have implemented the analytics function, which is very, very powerful and very simple to write. You just need to understand the syntax. So in this case, the way you can implement that functionality is you can say select p dot star comma rank, okay, over partition by, on which field we want to partition by, product category ID. So within each product category. So this means we are asking to group by product category ID, and then within each product category ID we need to order by product price, and that too in descending order. Okay, and then we will give the name as RNK from products P. Okay, there is no need to use group by or anything. If you want, you can say order by product category ID and then rank. Okay, and hit enter. We will see several examples. This is very, very important. Okay, there are different queries. I mean, so different categories where this comes handy. One is ranking. One is another use case is you want to get average. So if you take a department, and if there are n number of employees in each department, and if you want to get the percentage of the salary of that person as within the department. Okay, we have to first get the department wise total, and then uh, total of the salary, and then each individual salary has to be divided by the department wise salary. Then you will get the ratio of your salary against your department. So that is another scenario. And there is another scenario using something called lead and lag. So all these things I will try to cover. Okay, now you see. Yeah.
How can you restrict the number of records within
I am getting it. I am getting into that. So now you see within each product category, the prices are in descending order. Okay. Now, if I want to just get first three rank products, what I can do is some products. Okay, here you can say where R and K less than or equal to 3, and then order by. Okay, so here this will not work because this R and K will only be available for order by. Apart from order by, if you are using where or group by or having class, this R and K will not be available within that query. Now what you are supposed to do, you have to use nested subqueries. So what you have to do is select star from, and then use these two lines. Okay, give the name to the query where R and K less than or equal to 3, order by product category ID, comma R and K. Okay, and hit enter. So this is how you have to write. You have to first nest it, because whatever you are referring in the select class, it will not be available in the where class typically, where class or group by class typically. Only it will be available is in the order by class. There is a reason for that. So traditionally, right, all the SQL engines, when you write a query, okay, first it will evaluate the from class, then it will evaluate the where class, then it will evaluate the group by class. Once these things are evaluated, instead of evaluating order by class, it will go back to the select class and it will try to evaluate whatever is there in the select class. Because order by is evaluated after the select class, if you give aliases to the as part of the select class, those fields will be available to the order by, but not to the where clause or group by traditionally. Okay, but in Hive, some things are available in group by. When I ran last time, few minutes back, in one particular scenario, I mentioned that yeah, here is the query, right? So if you look at the query as part of the group by clause, either you can have this one, or you can also have order mark. In the group by, it will work. Hello? 2 minutes, okay? Okay, so now you got the data, and you see all the hundreds are given as rank 1 in this case. Okay, and because okay, so the default functionality of the rank is if there are collisions within the rank. For example, this 100, it repeated almost how many times? From 1, 2, 3, 4, 5, almost 15 times it got repeated. So the next rank will be 16 if it is repeated by 15. That is called as sparse ranking. Okay. If you want to give 2, irrespective of number of times it repeated, the first rank is repeated, instead of using rank function, you have to use dense rank function. That's the only difference. So here I am saying select dense underscore rank. Okay, and then okay, that's fine. You can actually go back to the previous results. And see here, right? After 1, it went to 15, 16, 17, 18. That's why when I say RMK less than or equal to 3, it only get to number 1 ranked products. Now you will see after 1, even though it repeated so many times, it will go to the 2, 3, etc. Now you can see 2, 3, 4, 5, 5, 6, 6, 6, 6, 7. So this is called as dense rank. Okay, so these are the functions, and to get to the list of functions, you can actually go to windowing, over, and analytics. Okay, so windowing functions are lead, lag, first value, last value, and then over. And analytic functions are rank, dense rank, cumulative distribution, percent rank. You can also get percent rank, row number. You can just get a row number also, so on and so forth. So we will see some examples with respect to count, sum, mean, max, average, etc. And also we'll try to get understand lead and lag also. Lead, lag, first value, last value also. Okay. So that being said, that's it for today. We'll catch up tomorrow unless anyone have questions online in WebEx. I will take those questions. Okay, windowing functions are very, very, very powerful. Actually, I worked for AT&T, and uh, some of the queries were taking several minutes to almost a couple of hours. And I used windowing functions and also some other tuning techniques, but predominantly I used windowing analytic functions, and I bring down all the queries to sub-seconds, like 2 to 10 seconds. Very, very, very powerful. And if you know Oracle, I can explain in the terms of how it actually runs internally, and why it is so powerful compared to self-joins, etc. I will conduct a SQL workshop very soon. In that, I will cover those things. Okay, so that being said, thank you. And those who are on YouTube Live, thank you very much for joining the session. If you like the video, please click on the like button. If you want to provide the feedback, so you can actually click on the like button here. If you want to provide the feedback, once the video is streamed, you can actually provide the feedback on the comment section of the video. And if you want to share with your friends, just click on this and share with your friends. If you want the environment to practice, just go to labs.itversity.com, choose one of the plans, and sign up for the lab. And if you have any questions, you can definitely follow up with us on discuss.itversity.com. We'll be glad to assist you. That being said, thank you. Bye.
Thank you.